So a confidence interval is a means by figuring out, is the sample data I collected, so if I surveyed you guys, is that sample data a representation of the population, essentially in the normal distribution? So if I survey you guys, 15 people in the class, and 25% are planning to catch the bus today, estimate the proportion of the school population that will catch the rest of the school population that will catch the bus today. So I want to be 95% confident within that range that these people are going to catch the bus or not. So the first step is figuring out that z-score. So if I remind you of the normal distribution, what's the mean for normal distribution? 0. So I'm looking for 95% under the area, under the curve. So 95% area under the curve, so 0.95. So what would be the area outside the curve? How did you know that? Yep. So these areas added together, because the total area under the curve is 1, remember that? 100% probability. So to find that combined, it's 1 minus the confidence interval. And to find the area either side, u divided by 2, because it's symmetrical. So why do we do this? Anyone know? Why am I figuring out this?
Because that gives you the probability of those little tails.
Yeah, it'll give the little tails, and that'll give me the z-score. And I can use that z-score for the confidence interval formula, and that'll give me the confidence interval. So then you can use your good old inverse norm. Do you remember doing that on your calculator? So if you have your calculator handy, turn it on. So before I do the calculator, I need to finish this red bit here. So this is equal to 0.0. So that's the area within each of those tails. I think the textbook uses the letter alpha to represent this number that we calculated, or the Greek letter alpha, if you didn't know. So it's like an A with a, yeah, you guys have probably seen it before. Yeah, some people call it the fish. So then we go to our calculator, menu, stats, where is it? Confidence intervals, distributions.
Inverse number 3.
Number 3, inverse normal. Type in your area. So that's the tail area, and that gives you your z-score. So approximately 1.96. So if you want to write down the shortcut, you can as well. It looks like this. The area, comma, the mean, comma, area, comma, comma, the mean, comma, the standard deviation. It's 1.96. Now we use the formula. So it looks like this, the confidence interval p hat, which is sample proportion, plus or minus the z-score, times by the standard deviation of the sample. Does it tell us the standard deviation of the sample in the question? It tells us the number of people in the sample. It tells us p hat, 25%.
Oh, you can calculate, right?
So we need to calculate this thing here, the sample standard deviation. So if you look at your handy formula sheet,
The lower Z value rather than the higher one.
so this is your formula for the standard deviation. So we can sub that in instead of the other one. Sorry, I forgot the square root. And then pretty much the last step is just subbing everything in. So the sample proportion is 25%, so 0.25 plus or minus the z-score we just figured out, and the p hat times 1 minus p hat divided by how many people did I survey? 15 of you guys. If we just take the time to type all of that into our calculator, our confidence interval is going to be 4, 7. So what does that tell us about the sample? So when I surveyed you guys, I knew 25% of you were planning to catch the bus today. What do those two numbers I determined tell us about the rest of the school and the bus?
Between 0.3% and 47% of the rest of the school will be catching. Are planning to catch the bus, which is very long range.
So yes, I am 95% confident between 3% and 47% of the people at this school will catch the bus.
Yeah, give or take that.
It doesn't really help us too much. How would I reduce my 95% confidence interval? Correct. I would survey more people and then I will get more confident. And I will reduce my massive percentage range of 3 to 47%. How do you know that will reduce? Correct. So you notice possibly in here there's little n. So the bigger that number is going to become, the smaller that overall plus or minus bits is going to become. So you could go the other way